Welcome to part 13 of this Python course, where we look at a real-world example, the visualization of data recorded during the analysis of an electronic circuit. The data, which is contained in a CSV file used in this example, can be downloaded from the link below. Let's assume that you have analyzed an electrical circuit and all the data from the analysis has been stored to a CSV file on a disk. You need to now read the data that's contained in that CSV file and plot it out so that you can actually visualize that data. The data that I'm going to be looking at is contained inside this file here called circuitresponse.csv. So I'm going to start off by importing pandas as PD, and then I'm going to import our matplotlib.pyplot as PLT. And then I need to specify the file name. So our file name for this is going to be on our E drive, our temp folder, and the file is called circuitresponse.csv. I'm going to use the pandas method to read the CSV file directly. And let me put the code in first and then I'll explain it to you. So I'm going to read our CSV file using pandas directly into a data frame. Column of data is named. All right, so I'm going to give a name to each column of data as I import it. So I'm going to create a data frame, which I'm going to call df, and that is equal to PD. Remember, PD is the pandas name, dot read underscore CSV. So that is a method belonging to pandas. And if I open my parentheses now, I'm going to specify the file name, and then I'm going to tell it what the delimiter is. A delimiter tells your program how your data is separated. And I'm going to use a comma as the delimiter. Finally, I'm going to tell it what names to use for the columns. So I'm going to specify names equals, and those names are going to be inside a list. It's going to be, the first column is going to be time. The second column will be our untuned data, and our third column will get the title tuned. Just to make sure that we've got it, I'm going to say print df, and let's see what happens. So I don't need to print it out. That was just to check that it is working. So the next step along this journey is to now convert the columns of data into lists. Why do we need lists? Because we want to plot it out. And as you know, matplotlib needs to work with data that's contained in lists. So we're going to create a list called time, and time is equal to df. We've got a column of data called time in there, and I'm going to convert it to a list. I'm going to do the same for the untuned. I'm going to create a list called untuned, which is df untuned dot to list. And finally, our third column under tuned is going to be df tuned dot to list. So what I've done is I've created 3 lists. Each list has a value. So the time list contains all the data contained in the second column. The untuned list will contain all the data in the third column. And finally, the tuned list will contain all the numeric data in the fourth column. So now that we've got our lists, plot the responses using matplotlib. plt.figure. I'm going to just make it slightly bigger so that you can see what's going on. I'm going to say fig size equals, I'll choose the 9.6, and then we can plot it. plt.plot. How do we use the plot function? We specify 2 lists. The first list will be time. The second list will be untuned. And the label will be equal to untuned. We can then plot the next set of data, plt.plot. Again, we are plotting the list versus time. So we've got the time list, we've then got the tuned data, and finally we specify a label so that we can identify which graph is which. And I'm going to say label equals tuned. Now we can annotate the graph. plt.title circuit response. plt.xLabel will be time in seconds, and plt.ylabel is equal to amplitude. So there's our graph annotation. We can now specify the extent of the graph. That's the x limit and y limit. So plt.xlimit. This data is between 0 and the maximum value of our time list or time vector, and plt y limit is going to be from 0 to the maximum value of the untuned list. And then finally, we can show the legend and the grid, plt.grid. So if I finally run that, we end up with a plot showing us the response. Now bear in mind that we didn't generate this data, we have read this data from the CSV file. And there it is. We've got our untuned data, which is in blue, specified in the legend, and the tuned data in orange, which is a much better response of our electrical circuit. Thank you for watching. If you found this video useful, please give a thumbs up and subscribe to the channel.